Hey everyone, and welcome to The Explainer. Today, we are talking about the absolute unsung heroes of the industrial world, pneumatic systems. I mean, they power the whole shebang, right? Everything from massive manufacturing floors to super intricate robotics. But, well, too often facilities treat these setups like they're practically invincible, right up until the moment they catastrophically fail. So today, we're going to shift our mindset. We are moving away from expensive, panic-driven reactive repairs and shifting toward highly profitable, proactive maintenance. To really understand the stakes here, I want you to consider this number, 20 to 30%. Yeah, you heard that right. According to maintenance data, that is the amount of compressed air lost to leaks in poorly maintained systems. Just imagine generating all that incredibly expensive energy, only to let up to a third of it literally vanish into thin air. It's wild. These invisible leaks, worn-out seals, and the pressure drops that follow, they aren't just minor background noise on the factory floor. They are a massive, massive financial drain on your operational budget. Think about it. When you lose pressure, your compressors are forced to work overtime, your actuators start getting sluggish, and your energy bills, they skyrocket. But the good news here is that this is entirely preventable. Okay, let's dive right into this. Here's our roadmap for today's explainer. Safe installation and routing, handling extreme conditions, air treatment and filtration, routine maintenance checklists, and finally, how to maximize your equipment's overall service life. Section 1. Safe installation and routing, where we set the foundation. So look at this. One of the absolute most common installation errors out there is using your bare hands to twist a pressure gauge into place by gripping the outer case. It seems harmless, right? Actually, scratch that. Doing this causes immediate, massive mechanical damage to the delicate internal gearing. You lose all your accuracy. Instead, the golden rule is to always use a wrench directly on the gauge socket. It takes, 2 extra seconds, and it prevents irreversible friction damage right out of the gate. And beyond the components themselves, how you actually route the air matters tremendously. If you tie a gauge or a valve directly into a rigid pipe, you are basically transferring immense plumbing strain and machine vibration directly into your most sensitive parts. It's a recipe for disaster. So, you should definitely be using flexible tubing connectors wherever you possibly can. And for those long-distance polyurethane tubing runs, use routing software to map out paths that avoid sharp bends, and make sure you support those long runs with plastic clamps at regular intervals. By minimizing that friction and vibration, you're actively extending the life of your entire setup. Section 2. Extreme conditions. Handling the heat, pressure spikes, and chemical threats. Now, if your system is facing down any extreme environments, a standard installation just is not going to cut it. Let's fire through some of these mandates. If you've got rapid pulsations or pressures hitting over 600 psi, you absolutely must use a piston-type pressure snubber. That's going to dampen the violent force before it literally destroys your gauge. Working with high heat, you need at least a 5-foot connecting pipe so the heat can dissipate before hitting the measuring element. And if you're tying into steam lines, well, you've got to install a water-filled pigtail steam siphon. It's this ingenious little device that sits between the gauge and the steam line to ensure your gauge's internal parts don't just melt away. Okay, this part is absolutely critical for your safety. Chemical compatibility. If you are using liquid-filled gauges, like glycerin or silicone to dampen vibration, you have to know exactly what media is flowing through your lines, because mixing a glycerin-filled gauge with strong oxidizing agents like chlorine or nitric acid, that simple oversight can trigger a spontaneous, catastrophic chemical explosion. No joke. Always, always verify your media compatibility during the spec phase. Moving on to Section 3. Air treatment and filtration, protecting the lungs of your system. Now, what's really interesting here is this FRL unit. That's your filter, regulator, and lubricator combo. See those polycarbonate bowls hanging down at the bottom? You've got to visually inspect those on the regular for any cracks, cloudiness, or heavy moisture buildup. Because inside those bowls are the filter elements that are actively working to pull debris and water out of your airstream before it gets the chance to ruin your expensive downstream machinery. Clean, dry air is exactly what keeps your valves from sticking and your cylinders from corroding. But of course, those filter elements don't last forever. And when a filter clogs up, it causes pressure drops, which, as we talked about earlier, completely spikes your energy costs. A lot of manufacturers make tracking this super easy with a color coding system. For instance, a yellow 25-micron particle filter, that should be swapped out every 6 to 12 months. Meanwhile, that ultra-fine red coalescing filter is going to need a replacement every 3 to 6 months. It's such a quick, low-cost maintenance task, but it pays massive, massive dividends in efficiency. Section 4. Routine maintenance checklists, making that shift to proactive care. Let's start with the short-term checks. Draining the condensate from your receiver tanks every single day is literally your #1 defense against internal system rust. You'd be surprised, but a single neglected tank can accumulate gallons of water in just 1 week. So, drain the water daily, do a quick visual check for leaks, and then, on a weekly basis, just verify that your filter bowls aren't overloaded with moisture and that your lubricators have the correct oil levels and feed rates. And this breakdown brilliantly illustrates how spreading your deeper audits out prevents major downtime. Every month, you should be conducting comprehensive leak surveys, ideally using ultrasonic equipment if you have it, and inspecting your rod seals for bypass leakage. Then, on a quarterly or semi-annual basis, go ahead and swap out those saturated filter elements we just talked about, and take the time to calibrate your pressure gauges. This keeps everything perfectly dialed in and running right to spec. Section 5. Maximizing your equipment's service life, the ultimate tutorial. Let's move on and see how this all builds into one cohesive lifecycle strategy. Step 1, be smart and plan your routing to minimize any vibration and friction. Step 2, get the installation right safely. Use socket wrenches on gauges and always opt for flexible tubing. Step 3, relentlessly manage those costly pressure drops by proactively tracking your filter elements. And finally, Step 4, lock in all of those gains by rigorously executing your daily, weekly, and monthly audit schedules. So all of this leaves us with one final, pretty vital question. Think about your facility right now. Are you just waiting around for your pneumatic system to fail, or are you proactively protecting your bottom line? I challenge you to take the insights we've covered in this explainer, go walk your factory floor today, and do a real audit of your airlines and maintenance routines. The energy savings and the increased uptime, they're right there waiting for you. Thanks so much for joining me on this explainer, and I will see you next time.